Hi everybody, my name is Thomas. I perform the research at the University of Ghent in Belgium, and in this video I'm gonna try to explain a little bit about what this research was, what I did, and what conclusions we've come up with. So the title is Management of Polyglot Persistent Integrations with Virtual Administrators. I'm gonna dive right in, right? So the content of this presentation is listed here. So first we're gonna start with the domain, and the goal will come forth from that. We used Juju and we created a proof of concept in the form of a use case. And I will form a conclusion and end up with a summary of all the previous things we discussed. And more or less, if there are questions, they can be asked at the end. Right, so once again, the title is Management of Polyglot Persistent Integrations with Virtual Administrators. And if you look at the title, there are two main things that are present, right? So on one part we have virtual administrators, and on the other, polyglot persistent integrations or applications, right? Before I will explain those two things, let me put attention on the fact that we're busy with system administration, right? We're operations kind of thing. It's not like we're trying to implement some kind of algorithm. It's not like we're trying to create an application, a web shop, or whatever. No, we're solemnly focusing on the deployment and the setting up part and the system administration in general of services of machines, right? So that's an important distinction to be made, and it will be clear later on why I am emphasizing this right now. So virtual administrators, right? It's a bit of a bloated term, really, because a virtual administrator is nothing else than an administrator that is not real per se, right? So virtual administrators can be anything. Right now, if you have a use case, for example, where you are in need of an Apache server, you would go up to your system administrator or your operations engineer and you would ask him, please, can you provide me a machine and configure it with Apache so that I can use it, right? Well, these exact same words and that exact same question could be asked to a virtual administrator, and he, or in other words, it, would perform the same steps that otherwise a person would manually do, right? So a virtual administrator does the exact same thing, but it's not a physical person anymore, and it's, in other words, in an automated way. And the most easiest way to look at it is nothing more than a command, a tool, or maybe just a bash script, right? It's nothing more. So don't get too focused on that term, right? It's just an administrator that's doing stuff as if it was a real person, and the one requesting it performs or asks still the same thing. All right. So polyglot persistent applications, on the other hand, well, that's a little bit else. Polyglot persistent, well, it actually found its roots in polyglot programming, where it was said that it would be interesting to look at different kind of languages and choose the right language for the right job, right? So for one thing, Java might be more interesting than C# or the other way around, right? Polyglot persistent takes the exact same approach, but with database technologies or persistent technologies, right, to store data. So I put an example. If you have a web shop written in HTML5 or in PHP or something, and it is in need of two databases, but the databases are of different types, then you would, in essence, or by definition, have a polyglot persistent application, because it uses two different or multiple different types of database technologies, Postgres on one hand and MongoDB on the other hand, for example. So an application using more than one type of database technology is called a polyglot persistent application. All right? So what is the goal? The goal is actually doing what the title says. So once again, management of polyglot persistent integration with virtual administrators. Well, it means that we want to create a virtual administrator that acts as a person, well, the virtual person, to manage these polyglot persistent possibilities, right? So if a user requests, I need a database of type, and it can be whatever, then the virtual administrator should respond, sure, I did it, I configured it, and here are the connection details. And whether it was a MySQL, a Postgres, a Mongo, or something else, that shouldn't matter, right? and the user would end up with the same exact information as if it would have been a physical system administrator, right? So that's mainly the goal. How did we do it? Well, we used the Juju tool, right? And Juju is an open source application modeling tool. It has a lot of features. I won't go into too much detail as I don't have the time, but in essence, the Juju tool uses graphs to model things, model infrastructures, right? And well, we can discuss about the fact that they are directed or undirected, but there are no arrows on the relation, so let's go with undirected. And the main idea of these graphs is that each node represents an application, right, a service, and each relation shares knowledgeable information about these two services. So in this example, Apache is for example acting as a reverse proxy, and we have a WordPress connected to a MySQL slave and a MySQL master. Well, in this example, WordPress actually needs a database to work with, right? So it needs something, and MySQL doesn't really necessarily need something to work with, but it provides a database. So adding a relation between WordPress and MySQL is just like puzzle pieces fitting together. They are actually sharing a shared entity called a database. And the whole idea is, if you do this, if you act with these models and with these charms, like they're called in Juju, then you're reducing a lot of operation overhead. In my thesis, I talked about operations knowledge, right? So we're abstracting and encapsulating that whole business. So a user does not need to know anymore how WordPress needs a MySQL database, how a database is set up. No, it just deploys a WordPress charm, it deploys a MySQL charm, and it adds a relation, and everything happens automatically, right? So that's a really cool stuff. So the proof of concept, which we wanted to do, the use case that I'm trying to follow in my example, because I needed a use case, because it wasn't clear always what I wanted to achieve. So I decided to create a use case to say, look, I'm going to try to implement this, and everything else will become clear from this proof of concept, right? Because there's so many use cases where the generic database service or the virtual administrator could mean different kind of things that I wouldn't end anywhere if I wouldn't take a proof of concept, right? So the proof of concept in this case is a company, right? And they decide to create a web shop application. And that web shop application has a requirement of 3 different databases, right? One for users, one for items, and for example, one for shipments. And they decide, the team, the system designers, they decide that the type of databases shouldn't be the same, right? So it's not all a Postgres, not all a MySQL. In this case, for example, the users is a MySQL database, the items is a Postgres database, and the shipments is a Mongo database. Well, it doesn't really matter, but they're different, right? On the other hand, the company also decides to create an application that will perform some analysis on data, right? In this case, on the users database, to see the geolocation of what items that is most on the geolocation of their users or something, right? So I hope you understand that the contents of the web shop application and how the data analysis app works and all of that good stuff isn't really relevant here, right? So we have 2 different applications, we have 3 different databases, and we have one database that is shared or that is needed by both applications, right? How would we do that in Juju? Or in other words, is it possible in Juju? And while it is more or less, but it will require manual steps. Let me explain. In Juju, these charms, the Mongo charm, the Postgres charm, and the MySQL charm, they exist. Just like the interface layers, which can be seen as relations. The interface layers explain users or charm authors how to write code that will use a Mongo database, MySQL database, or Postgres database, right? So first big remark, to actually use these kind of charms, the person who is writing the charm will need to look up and will need to see how does the Mongo interface works, how does a Postgres interface works, how does a MySQL interface works. That's the first big step. So there is suddenly operations knowledge, not on the same level of how does MySQL perform it, but how does the Juju charm perform it. So there's still operations knowledge involved. That's the first step. The second step, and I'm gonna show it here, is that the default behavior of a lot of charms is as soon as a new charm enters the fray, right? So as soon as a new relation is added, a new database will be created. So in this case, in our case, the MySQL charm would create two different databases, which is not something we want. We want one and the same database. So while right now in Juju it would not work in a fully automated way, we need manual intervention, which is, well, kind of sad. So that's what I wanted to solve, right? So the proof of concept that I created and the generic database service, which I called Atomic, is in this case the middle charm, right? The blue database icon. As you can all see, this is a Juju GUI, which is available for Juju itself. And the idea is that my data application and my web shop on the left of the screen, they are the one requesting it, right? And all they do is request a database to my generic database server. So all they need to do is add a relation and literally type in the code request MySQL, comma, users. Request Postgres, comma, items. Request Mongo, comma, shipment. And everything else will be performed automatically by the generic database service in the middle, right? As you can see though, the generic database has the pre-requirement to be connected with other services, and these other services need to be deployed and ready to function. So in this case, Postgres, MySQL, and Mongo. So as you can see, each generic database is connected to the three database technology instances or services, right? But it works, the proof of concept works. Each configuration file gets rendered on the web shop and the same database information gets rendered on the data application. So the proof of concept is more or less a success, right? Now, people can say, and it is a choice, I talked about the Atomic generic database, I choose to have a semantic meaning of that specific node in the middle, the generic database. I chose to say, look, this service only represents a generic database which becomes concrete. In other words, there is either the possibility to request a generic database or there is a database for you at your disposal. If you connect, you will receive the details. There is no, or I decided to add no support to back up the database, to create users on the database, to execute a query on the database. I found that it would be, well, it would have been the role of a database administrator. And I decided in a theory crafting session of mine that a new service that would connect to the generic database services would be able to do that. So you could create a new service that uses the Atomic generic database services to perform these kind of tasks. I did not implement it, it's not functional, but there are some prototypes, right? So you could, for example, add a relation from the web app to the database administrator service. You could say, look, I need or I want my database to be populated with some dummy data, and that service would be able to do so because it would receive the details of the generic database, right? So I think it would be most clear to not put them together, but you surely can. I mean, if you decide to add support, to add that third library, to make a connection in Python and to populate the database, there is no reason not to. But I wanted to make things as simple as possible and to make a clear distinction between the two. All right. So I want to get back to the beginning of my presentation. I talked about how important it was to keep in mind that we're talking about operations and system administration. Well, here we are again. The operations side uses the generic database service and it uses the underlying relations. But from the applications point of view and even from the database point of view, once everything is done, the connection that's made by the application is direct. It's one and the same. These endpoints, right? They do not know anything about Juju. They do not know anything about the generic database service. So the application is still making a direct connection towards the database. It's not like it's going over, the data flow is not going over relations, over the generic database service, and then so to the database. Keep that in mind. There's a clear distinction between the two. That's something important that I need to emphasize, right? So conclusion, right? The proof of concept was a success, which I already discussed, but there are some caveats, right? It's a bit of a yeah. There are things that aren't as clean or as efficient. First of all, the model becomes bigger, so there are more nodes, more resources. On the other hand, I said there are preconditions, right? Pre-requirements. I need my MongoDB service up and running, and I need a relation with it. I need the same with MySQL. I need the same with Postgres. On the other hand, if you want 10 databases, if one application is in need of 10 databases, then you will need 10 atomic generic database services. That might be something you don't want to. All right? On the other hand, the implementation that I created in the atomic generic database service showed a lot of, well, weak spots, more or less feature requirements that I needed in existing interfaces, right? For example, right now I need to add 2 connections over 2 different MySQL interfaces to get what I want. Right now I need PG Bouncer because a direct connection with Postgres would limit my actions. I won't go into details, they are explained, but it showed that a lot of more work could be put into the existing interface layers, which is interesting, but I limited myself and I said, look, I don't want to edit anything about the existing interface and charm layers. But it showed that it might have been interesting to do so. And finally, there's a lot of room for more optimizations in the service itself, more database technologies, like Juju, to actually look at. And on the other hand, research, right? It could be interesting to look at other services who would use the generic database service and who would add more to the automatization level. For example, it would be interesting to look at what requirements has an application, what does it use, and determine with these requirements what type of database technology is best suited, right? Simply a research about when do I use MySQL over Postgres, or when is it interesting to use Mongo, something like that is a very interesting research, right? And very modern. When do we use which database technology? I think it's really interesting. All right. So I will wrap things up. This is a short summary of what we discussed. The title is once again Management of Polyglot Persistent Integrations with Virtual Administrators. We tried to create a generic database service as a virtual administrator, right? Who would be the manager of these kind of things and who would actually automate the whole process. The proof of concept was a success, so we created a service, a charm in Juju. It was a success, but there are still some, well, caveats, right? It's not always as efficient as it should be. All right, I'm gonna end this here. Thank you everybody for watching, and if there are any questions, you could always contact me. Thank you.